Hello, today we will be starting our new course. It stands for CAECM and it's a professional course for Department of Aeronautical Engineering or Aeronautical Engineering students, and it's with code of C29. Myself, Sai Krishna, working as assistant professor in Department of Aeronautical Engineering from the Institute of Aeronautical Engineering. Today we will be continuing this course to see how computers are assisted in the age of manufacturing. Right? For now, we'll start with what do you mean by CAE or CAM. Right? As a part of your module 1, we will be discussing how well the computers are used in industrial manufacturing age. Next, what do you mean by product cycle, and what is the CAD/CAM hardware that is applicable for you, and what is the graphics coordinate system that is used while creating few graphics, particularly CAD models, as well as what is the database structure that is applied for the graphics modeling, and what is the transformation of geometry, three-dimensional transformations, and what are the product mathematical projections, and clipping and hidden surface removal. All these topics we'll be covering under as a part of your module 1. So next, continuing with your first, what do you mean by computers in your industrial manufacturing? Right? What is the role? First, computers in use of industrial manufacturing are broadly classified into two. First is your computer monitoring. Second is your manufacturing support. Right? Particularly, computer monitoring is basically for monitoring and controlling of manufacturing processes. Right? In what way? Basically, let's say computers are directly interfaced if we are producing few products. For example, a pen, right? A pen is again, whenever we are manufacturing pens, handmade production of pens are currently a bit tedious process. So in order to overcome this particular process, what we'll be doing, we'll be integrating computers, right? These computers will be assisting us in creation of pens. Now, what does this computer form is dependent. First, if you are using computers while attaching themselves to the companies or attaching themselves to the manufacturing machines in order to enhance your productions or enhance your productivity, at that time you're calling it as for monitoring and control, right? And second is your manufacturing support applications, which includes all the necessary processes for which the computers are assisted for, to be precise, for actual as well as post manufacturing operations. Right? For example, we'll cover this with a better example. Let's say we are creating a car. Right? A car is made up of particular machines. Right? And in order these machines to perform effectively, these machines are embedded with your computers. Right? These computers will help control the machines in order to get your car as a product. Right? And now, if you are using computers instead of your manufacturing for every other process, let's say in order to procure some material, to plan how you are producing your car, everything, those will be your manufacturing support applications. These will indirectly affect your production of your car, but directly it will not affect. These are two categories that we can classify them, right? And the next, what is the influence under computer manufacturing environment, right? First, we'll start with your computer aided design, right? Basically, this means we are creating features as well as solid models in using CAD softwares, particularly CATIA or ANSYS, right? In this modeling software, what we will be doing is basically we'll be creating a solid model, right? Solid model consisting of geometry that we want it to be designed or it to be produced, right? Next, what is the parametric as well as variation model? Any changes, right? Any changes in a single model, if you want it to be happen, you can modify it digitally in the same software. It will maintain certain documentation or track that is necessary to keep a record of for the same, right? Next is your computer graphics. Computer graphics will enable you to look digitally an object in its three-dimensional perspective, right? If the same object is available in a real-time cycle, how well it will be looking, that you can go do under or observe under computer graphics. And graphic standards, let's say if an object of material, let's say aluminum or steel, that particular kind of material, look how it is observing. The same thing, if you want it to be shown on it, that you can show it under according to the standard of the material or texture of the material that is available predefined. And IGS, DXF as well as STEP. These are the design formats that are available for creating a geometry. Whenever a geometry has been made, these geometry models are saved under one of these three or any other formats which are suitable for interchangeability of the geometric constructs, right? And your design analysis too, preliminarily, what it basically does is it will analyze what kind of is a design is correct or not based on the constraint, based on the necessities that you are performing your design. And FEA, FEM simulations and mechanism test analysis, all these are related to your analysis of your design, whether it's a valid design or not. If the design has been validated, at the time you can proceed further for creating of a drafting as well as creating of your product out. If not, it is again reverse sent back to the design process where it is alterated or changed back to the whole process until unless the design has been achieved, right? Next, we will be going for manufacturing systems, right? Whenever a product has been ready in terms of digitally speaking, creating a draft, that will be sent back to your manufacturing system. In a manufacturing system, what will be using computers particularly for in order to have your mechanisms, production activity, machining, assembly, all these functions are related to your getting your product out. And the last is nothing but your quality control. How well the product that we identified for it to produce, how well it is maintaining its quality at the end of the production cycle, right? If the quality is not has been satisfied, we will change few iterations or few operations accordingly to update the manufacturing process to get it out. And next, we will be using computer assisted manufacturing, right? Under this, what we will be doing is we will be using computers in order to assist manufacturing operations, particularly to plan a process, to create a production plan, and to create a part program for CNC machines that we will be using, and any robot programming or any coordinate measuring machines, right? All these things we will be planning with the use of computer aided manufacturing, right? We will be using computers to get the information generated that has to be fed to the machines. Next, what we will be doing, we will be using business processing, business data processing. During those whole three cycles, what we will be having? We will be having a data related to your factory level production, product management, what is the bill of materials, what is the capacity, what is the inventory, and what is the materials required. All this we will be having under the same. All this is the data that will be generated during your manufacturing environment. Along with this, few marketing data related to business, particularly financial management, costing, sales, purchase orders, vendors, personnel, all this data will be generated during your complete manufacturing of your product. And during this, what basically happens is you will be using key systems, key computer integrated manufacturing technologies. Those are particularly used using the computer networks as well as designing a system as well as analyzing for the same, and distributed processing, database management, modeling and simulation, expert systems, quality engineering. All these are the key important technologies that you will be using while undergoing or while applying computers in an integrated environment for manufacturing. Why? This we will discuss further regarding SIM. Now coming to your next is your design process. Design process are basically classified under two sections. First is your product engineering, second is your manufacturing. While coming to product engineering, first we are supposed to understand what is the product and what are its functions. For example, let's say you take a water bottle. right? We'll understand with the example of water bottle, which is a common product. For this, we'll understand the functions of water bottle. It is supposed to carry liquid, particularly, although it is made for water, we are using for other few liquids also. So we'll consider it is supposed to carry a liquid in it. So this carrying of liquid is a function of water bottle. Now, how you are going for next step, what is the product specification that you particularly require is, let's say you're creating a liter water bottle, 1 liter of capacity of water bottle. The same liquid should be of 1 liter, right? 1 liter is the volume of liquid, volume of fluid that you are supposed to carry in your product, right? Next, what is the conceptual design? A simple container with capacity to carry 1 liter of liquid, 1 liter of liquid, right? And a few nozzle design to pour it in, ease to pour it in, right? Now, all these three are your basics, right? Next comes your ergonomics or aesthetics. Basically, ergonomics are related to your how well it is functioning, and aesthetics is how well it looks, right? Considering these two, what we can do is we can get a bottle which has certain amount of grip, certain amount of shape, so that the person can hold it better, right? And a small cap in order to easily drinkable from inside to out, as well as easily pourable from outside to in if you want to refill in every case, right? So these are few aesthetics and ergonomics that we want basically. Next is your standards. What are the standards you want to follow while drafting the bottle or while creating a water bottle? Is basically you want 1 liter of liquid that you want, right? This liquid you're supposed to pour it on with standard conditions of water should be standard quality, material should be standard quality, what kind of material you are using, that is also dependent. Next is your what is the detailed design that you can get. Detailed design stating the shape, the material, the shape, material as well as few other processes, right? All these are under your detailed design. If you are leaving the process out also, your shape and material, at least these two should be clearly mentioned in order to get your product out. Next, based on this, based on your design, you are supposed to do what? You are supposed to simulate, that we will see later on. First, you create a prototype. Prototype is nothing but a small sample of your product that will be developed early in order to get your physical feel of the object as well as your content. Next, what you will be doing, you will be testing and simulating the same, right? Physical testing might include destructive as well as non-destructive as well as physical testing, right? All these things will see how well the product acts in a real life or real time. Whereas simulation is nothing but recreating the same environment digitally to know how it will be affecting in all the test cases. At last, if under product engineering, if everything is fine, right? If the bottle passes all the simulation tests, at that time you will be sending it for analysis as well as drafting. You will be analyzing the results. Then, if you're satisfied with the analysis, then you will be sending it forward to your drafting. If not, you will be sending the bottle back to its development, either your product specifications or aesthetics, in order to improve it further, such a way that the desired analysis or desired output of the product happens. Now, as the drafting has been done, the draft is nothing but a simple 2D sheet of paper which contains all the processes, all the design of all the 2D geometry scale model of the product that you want to be manufactured. Now, the same model will be sent back to your manufacturing engineering, right? What does the manufacturing engineering does? Basically, is it will create a process plan which includes what are the different various processes that are involved while manufacturing a machine or while manufacturing a bottle. Now, what is the tooling required for manufacturing this particular bottle, right? And next, what is the information generation required for the product? Next, organization as well as marketing. We'll discuss this one by one. What is the process plan, right? First, what we'll be doing is simple bottle. What is the process we'll be using is basically not injection, we'll be using blow mold, right? Blow molding is one of the manufacturing process through which a bottle is being manufactured. So before that blow molding, you're supposed to see before the starting of a blow molding, what are the required ingredients or what are the required processes that are need to be done before blow molding. If you can see any of the manufacturing process of bottles, you will be see some pegs. Pegs are nothing but small capsules which include threads at the top, which is nothing but your mouth piece of your bottle, and last is your plastic casing, small test tube similar to kind. Now this is being heated, then again molded back using blow molding to get your shape of your bottle, right? This is your basic process. And before starting off your pegs, what you want? You want raw material, which is also known as granules of either PET or PLA, depending on the type of material you start, right? As the material, getting your material, form them pegs, and the pegs will be formed to blow molding, then again cooled. So you can see this whole thing is a process, right? You're supposed to plan this process according to the standards the bottle is being required to be made, right? Later on, next, in order to make what is the type of tooling you require, right? So already the process has been made. Next, what is the type of tool? In case of blow molding, what we basically is we need mold and die, right? These two are necessary in order to maintain a particular shape of the bottle, right? This tooling makes that, right? And according to the shape that we design, detailed design as well as draft, we'll create a mold. That mold will be used under the blow molding machine to get your product of your desired shape. Next, what is a manufacturing information generation is basically if any CNC, what we are considering is basically your blow molding machine. Next, if you're considering for any CNC machine or any, let's say, blow molding machine with computer assisted system, this machine, particularly blow molding with computer assisted system, what we can basically do is we can program the computer which is associated with the blow molding to hold the workpiece or the hold the bottle till a specified period of time till it has been set, right? The time that you program, right? The time that you know basically you're supposed to program it into the machine to let it know that it is supposed to wait for that particular period of time to get its original shape or desired shape. So in order for that, whatever the information that you are having, you're supposed to generate in form of code, particularly called as numeric code. This numeric code will enable or will let the machine know to perform or maintain that particular amount of time or specified operation. Next, how you are doing, you are organizing your production, right? Production is being organized based on your type of process, type of tooling, or the generation information. According to these first two, you will be doing what? Basically, you will be creating a line, production line, which contains according to the time that each process is taking and based on the level of productivity or based on the quantity that you require, you will be doing this. And at the last is nothing but your marketing and distribution. Each product has to be marketed in the market and distributed among the retail people. Now, this marketing chain is dependent particularly on the sales, right? Your product which has some value, let's say as we are taking an example, water bottle. The same water bottle has to be marketed in your area. Let's say for India, in India, a water bottle has to be marketed to at the end consumer called retailer, right? Oh, no, sorry, not retailer, consumer. right? Water bottle in India, till the consumer, it is to be marketed, because you are supposed to know if you are creating a product, the product has to be well known with the people, either in a particular region, to get the product sales running. So as the product sales run, you will be generating a revenue that will be used again back in doing either in the product development or creating your products. Right? Now coming the same, what about distribution? Right? Distribution of any product, particularly in our example water bottle, you will be having a separate sequence of operation that you will be taking there. First, under production plan, you will be producing your bottles, right? Those are to be shipped along to consumer use, using few retailers or distributors, right? From production plant till the end of consumers, you are supposed to go through distributors in order to get your product out. Now, the same thing, what you can see basically is what these distributors do. They distribute your product evenly, whereas not necessarily only evenly, whereas when needed to the consumers according to the demand that has been generated. Right? The demand based on your product requirement, the generated demand will be sent through. Next, we'll go through the design process. So first, what is the mean of your design process? We'll see an overview, then we'll continue with your individual elements. First, what is the first process in your design process is your problem identification and recognition of need. Let's say for water bottle, right? What is the need? First, what is the problem? Is basically to carry, you are not able to carry a particular amount of quantity of liquid from one place to other. So in order to ease that carry, that you are creating a product, right? Next, what is the recognition of weight? Is basically something that holds the water so that you can easily take it away from one place to the other. Next, how you are defining your product as well as conceptualizing is a simple container which holds a amount of liquid, particularly 1 liter, 1.5 liter, depends based on your product. Next, that is easy to carry as well as easy to hold, easy to travel, transport, everything in every aspect. Next, geometric model and spatial analysis. You are creating a geometric model of your bottle, how it's supposed to be looking, and you are creating a preliminary analysis whether if this is feasible or not. Right? Not the engineering analysis, it's a preliminary analysis. Next, we will be performing what? Engineering analysis as well as optimization. Engineering analysis, particularly in terms of FEA or FEM, you will be applying certain amount of loads, certain amount of pressures on which the product is supposed to stand. If the product fails, again, the data is again put back to your definition to redefine the problem set. If not, then it is again sent back to your prototype development. What happens in the prototype development? As we discussed earlier, you will be generating a real-time model which used for creating a model, testing same. Next, on base of your prototype, you will be creating your manufacturing process. Right? These manufacturing process will let you get out a simple plan which tell you that what to be used when. At the last, you will be implementing the same. Right? You will be implementing the same manufacturing operation and getting a feedback out. Now, if under manufacturing implementation, if you are finding out any difficulties, at that time, whatever the feedback that is being generated during the implementation is again fed back to its respective sections where sufficient alterations in the model or any of the sections are being made. Right? In this, during manufacturing process development also, if there are any necessities that are required, you can again send back to either product definition or your geometric model. Right? It's a complete cycle where you can apply the same.
Like, share and subscribe. Hit the bell icon for more updates.